All right, so today we're going to talk about the last part of measures of linear relationship, which is to find the equation of the least squared line. Okay. First of all, let me introduce you briefly what is a least squared line. Okay. If you have two variables x and y, first we can plot these data into coordinates, right? Such that, for example, here we have these points plotted in the coordinates. The least squared line is a straight line that which has an average whose average distance between this line and this point is least. Okay, we're not gonna discuss how we can find this line in grade 12. Probably you will learn this in your university study. Okay, all you need to remember here is the equation of this line. Okay, this line, the equation of this line is given by this formula, y hat. Okay, this reads as y hat. Y hat equals to b1x plus b0. Of which b1 is the slope of this line and b0 is a y-intercept. Okay, whereas b1 is a ratio between s and sxy and sx squared. b0 is the mean of all y's minus b1 times the mean of x. Okay, please write these formulas in your notebook. And I'll demonstrate how we can use this to find the least square line. Okay, so why is the least square line useful? The least square line is determined by these scatter plot. So once we have generated the least square line, we can then use the least square line to make prediction, right? For example, these data points are the samples we draw from the population. Okay, if we first plot this data into the coordinates, and then we find a least square line like this. Then for an ungiven point, such as here, for any given x, we can find the corresponding y values here, right? This is called prediction. That means for any given x values, we can predict a y value according to this least square line, right? So one of the purpose of this line is to make prediction. Okay, I'll show you an example of how we can get the least square line from the scatter plot. Okay, let's see this example. A tool and die maker operates out of a small shop, making specialized tools. He is considering increasing the size of his business and needs to know more about his costs. One such cost is electricity, which he needs to operate his machines and lights. Some jobs require that he turns on extra bright lights to illuminate his work. He keeps track of his daily electricity costs and the number of tools that he made on that day. These data are listed next. Determine the fixed and variable electricity costs. Okay, here it gives you number of tools he made and the electricity cost on different days. And the question asks you to determine the fixed and variable electricity costs. Okay, the electricity cost Y. Okay, assuming it has a linear relationship with number of tools he made, such as kx plus b. When x is 0, that means he made 0 number of tools on that day. The value of b is called the fixed cost, right? Because he did not make any tools on that day. These are the necessary electricity cost without making any tools. So this is called fixed cost. And the slope of this equation is called variable cost, which is the cost of extra electricity by making a tool, right? So if we can find the equation of this least square line according to the data points here, then we can find the fixed and variable cost. Okay, so the problem really becomes to find the least square line here. All right, let's see how we can do this. Okay, first I'll show you how to find the least square line manually, and then I'll show you how to do this using a computerized tool, okay? Okay, remember the equation of the least square line is given by a formula, right? The formula is y hat is b1x plus b0, whereas b1 is a ratio between sxy and s squared, and b0 is given by y bar minus b1 x bar, right? So we need to calculate these values and put them into the least square lines equation. Okay, first of all, we need to list all the values of x, y, xy, x squared, and y squared, right? Okay. These are the data you have already known that, right? And then you calculate the product of x and y's. and then calculate x squared. And then calculate all the y squared. Also, you need to calculate the sum of each column. All right, next, remember how to calculate SXY. How we can calculate the sample covariance. SXY is 1 over n minus 1 times, okay, first term is all the x, y product. Second term is 1 over n times the sum of all x, and then sum of all y's, right? So we put all values in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, the result is approximately 36.06. Okay, because B1 is SXY divided by SX squared, so we also need to calculate SX squared, which is 1 over n minus 1 and this gives us 16.06. Okay, so here we can get the value of B1, which is SXY over SX squared, which is 36.6 over 16.06, which is approximately 2.25. This is our slope of the least square line, okay? And then we can calculate B0, which is the mean value of y, which is 24. 241.86 divided by the number of data points. Minus B1, which is 2.25, plus the mean value of all x, which is 65 divided by 10. this gives us 9.57. Then we have the slope and y-intercept of this equation. So the equation of the least square line is y hat equals to 2.25x plus the y-intercept, which is 0.57. This is our least square line, okay? So the fixed cost as we have already discussed, the fixed cost is the y-intercept, which is 9.57, right? And the variable cost is the slope of this least square line, which is $2.25. Okay. Any questions? Okay, if you have no questions, let's proceed to the next measurements. I'll show you in a later time that how we can find this line in Google Sheets, okay? But before that, let's have a look at the last measurements, which is called coefficient of determination. Okay, by definition, coefficient of determination is defined as the squared coefficient of correlation, which is denoted as R squared. Okay, R is coefficient of correlation. The meaning of this measurement is coefficient of determination measures the amount of variation in the dependent variable that is explained by the variation in the independent variable. For example, the coefficient of determination is R squared equals to 0.758. This tells us that 75.8% of the variation in the electrical cost can be explained by the number of tools. The remaining is unexplained. Okay, let's see an example. Okay, we'll use the same example to illustrate how we can get the coefficient of determination. Okay, we'll continue work on this table. Coefficient of determination, I'll write it here. Coefficient of determination is R squared, right? Here, because it's a sample data, we use lowercase r. And R is a coefficient of correlation, which is defined as SXY over SX and SY. Okay, because here we already have SXY and SX. So all we need to do is to calculate the SY. Okay, SY squared is 1 over n minus 1 times the squared y values and minus 1 over n times sum of all y's to the square. Okay, which is this gives us 106.73. Okay, and then we plug these three values into this formula. Then we can get the coefficient of determination. Okay, first let's calculate R. R is 36.06 over square root of 16.06 and then square root of 106.73. Okay, then the coefficient of correlation is approximately 0.8705. Then the R square is 0.8705 to square, which is approximately 0.7578. This is our coefficient of determination. Okay. Any questions? Okay. One additional thing I need to mention is that when you interpret the correlation or determination, you have to be very careful. Because of importance, we remind you here about the correlation, correct interpretation of the analysis of the relationship between two interval variables. That is, if two variables are linearly related, it does not mean that x is causing y or y is causing x. It may mean that another variable is causing both x and y, or that y is causing x. Remember, correlation is not causation. All right? You can only say that x and y is correlated. It does not necessarily means x is causing y or y is causing x. Okay? Pay special attention to this. All right. This is how we can calculate the least square line and the coefficient determination manually. Next, I'll show you how to do this from computerized tools, such as Google Sheets or Excel. Okay, we'll use Google Sheets as an example. If you have internet connection, please open Google Sheets and let me show you how to do this in this tool. Okay, first, let's input. We'll use the same example to illustrate this. Okay, first, let's input all the data in the spreadsheet. Okay, first row, we have different days. Second row, we have value of X. Next row, next column, we have different Y, and then we need to calculate. We don't need to calculate the values because this tool can directly generate the values of the least square line and coefficient determination for you. Okay, because we have 10 days. Okay. Actually, you can also delete this row. I leave this row here just to make it clear which day is X is a pair of X and Y come from. It's first day we have X equals 7 and Y equals to 23.80. Second day we have X being 3, Y being 11.89. Okay, and we input all the data here. Okay. Then first of all, we need to draw a scatter plot based on these data. Select all the X and Y's and click Insert Chart. Normally, it will automatically generate a chart for you, but it may not be the correct chart you want. Okay, from the right-hand side chart editor, change it to click chart type, change it to scatter plot. Okay, now it looks like correct. And now we need to insert the least square line. Double click any point of this. Double click any point. On the right hand side, click Customize. And scroll down, find Trend Line. Make sure the trend line is selected. This is our least square line. Trend line is actually the least square line. Okay, and next we need to show the label. We need to show the equation of this square line and keep scrolling down, find a label here and click label, select use equation. And then the equation of this line is shown here. And also tick the show R square. This gives you the value of the coefficient of determination of this square line. Okay. As you can see here, if you use a tool to draw this least square line, it's much faster. Okay. According to the manual method, the least square line is 2.25x plus 9.57, right? This result is very similar to the square line generated by the Google Sheets. There are some errors because the methods they use and the methods we use have some minor errors because of the rounding up or rounding down. Okay, but basically these two methods are the same. The R square here is 0.759 and we get 0.758. 0.78, which is very close. Okay, so this is a computerized method of how we can get this least square line. Okay, I'll give you 10 minutes to try it by yourself, both manually and from Google Sheets. Make sure you know each method. Okay, in your test, you can only use manual method to calculate this line. Okay, but in your final project, you may use whichever method you feel comfortable. Okay, if you have any questions, you can ask here. Next, please spend 10 to 15 minutes. Make sure you are able to generate the least square line by yourself.